How's it going? I hope everyone's doing great. Last week we got the Bruin to bust off manually without using throttle body cleaner. We did not get the electronic starter to work. So today we're going to be doing a circuit test of that. We're going to be checking the resistance of the ground circuit for the battery and the circuit to the starter and start solenoid. And I'll be talking y'all through and showing y'all how exactly to do an ohms check for resistance in those circuits. So without further ado, let's get into it. All right, so this is just a standard digital multimeter. You want your black wire to go here, which is for ground, positive wire here. This meter tells you what it's for. This would be for amps. This is for resistance, ohms, voltage, all that good stuff. So you swap your meter to ohms. We're gonna take it. This right here is the battery ground. So let's just go ahead and check that and see what we get. All right, as you can see, we have half an ohm, which is less than half an ohm. We got zero resistance. And all I did was make sure you're not touching the lead ends and stick it to the engine block, transmission case, anything like that will work just fine. Yeah, see. All right, so there's no resistance there. Now we'll check end to end from our battery positive to the start solenoid. And when you're checking a hot wire like this, you cannot have power running on it. So that wire is good from the start solenoid to the starter. Is good. We have no resistance in those circuits, so we'll just be putting a new battery on it, and maybe it was just a bad battery and that's why I wouldn't start, but we shall see. All right, so we got the battery in here. Keep in mind when you go to do a battery into anything, primarily like these newer automotive vehicles, but it's wise to do it anyway. You want to do your positive first and then your negative, because you can arc the positive wire and it can run through the electrical circuit and fry modules and pop fuses and whatnot. So it's best to do your positive wire first and then go and do your negative wire to avoid any issues of that sort. All right, so let's see what happens now. Let's see, there's that. Still nothing. We got lights coming on, but let's go ahead and lock that. All right, so we're definitely not getting powered any of that. This is just a standard test lot, a standard bulb in it. These are what I prefer. I got a LED one and it's good for quick checks, but the issue you run into is when you're checking a wire for resistance, as you can see it's lit up. See if I can catch that good. If, let's say this wire here had one strand and it was connected end to end, it would light an LED light up because of how little amps it actually requires to run an LED bulb, as where a normal bulb test light requires a lot more, and it's a true loaded test. It puts the circuit under load properly to make sure that if there's only one strand connected one end to end and all the others are broke, it will not light this light up, but it will light up an LED. So I definitely recommend just a standard bulb test light. They are way better for this sort of test. See, As you can see, the light, it lights up, which indicates voltage. But now, as you can see, make sure it's not a brake thing. We're not getting anything past our solenoid. We're good here. Voltage, nothing, which means we're not going to be getting anything at our starter. Yep, so something's up with our start switch right here, or solenoid. So if we can just get this pulled on out, see what we got. Yep. Yeah. Yeah, the fuse is good. And as you remember from the last, when we did the ohms check, the wires are good, so something's up with the start solenoid here. Let's see, that's straight off the battery, so make sure none of these are hot. Whoop. See, I guess you can do that too. Actually, let's see what happens. So now it's best to use a jumpered or a lead a jumper fuse with a jumper wire with fuses, but because if there's too much juice running through it or there's high resistance, we're gonna melt these, but just for a quick. Yeah. See, so we do have resistance somewhere. I think it's that bad connection there. So I think, so yeah, now that that's done, make sure the thing's not hot no more. Yeah, it's still a little warm. Let's see if we can do it. Ow, man, that sucker did get hot. Wire's hot too. Yeah. So we do have resistance somewhere. I don't know where the resistance would be though. I think what I'm gonna do is I'm gonna get a new positive cable, because let's undo it real quick. Alrighty. So let's check this wire one more time. So I'm thinking I'm gonna need this start solenoid. Where'd I put the voltmeters on the other side? Yeah. Yeah, see right here through the eyelets we don't have anything, so, or through the edge. Yeah. Alright, so yep, So what we're gonna do, we're gonna get this start solenoid off, and we're probably gonna get a new hot wire right here. The ground wire is good. We'll double check that, make sure we're good on that, just to be safe. Might end up needing an all it is the corrosion on the outside. But all right, yep, let's get the start switch off, starter solenoid off, and we'll see if we can't find a new one, get that coming. We'll see how much these are. I might replace this one. This one's good, we already know it's good for sure. This one's questionable. You can see all the rust on it. The one socket that's always hard to find, the 10mm. They tend to vanish. Can't ever keep 10mm ever. Alrighty then. Guess we'll do it the slow way. Maybe. We found out the start solenoid is bad. It will not do anything, but we also believe that the hot wire here probably is too high in resistance as well. That's why, as you saw when I was just jumping the solenoid, it started to melt down my jumper wire. So what we're gonna do, we're gonna get a new cable, new hot cable, battery cable, and a new start solenoid, and then we'll go from there. Thank you for watching. As always, y'all have a good one.